Go.
Hello everyone, my name is Leo and I'm here to present our CS536 final project demo. And our project is the mobile chatbot, and I worked on this with Mohammed, Dominique, and myself, Leo. Next slide, please. Yeah, this is a little, I guess, introduction or structure of the presentation or the demo. And we're just going to start with the introduction, and then we're going to jump into software and the architecture overview of the software engineering aspect. And then we're going to do a quick demo, and then we're going to show the field test result, and then we're going to do conclusion and future work, and then footnotes. Next slide, please. For our project, we are working on option 1C, ChatGPT on a mobile app. Our goal is to develop a prototype of a ChatGPT mobile app that works across different devices and experiments a new design that improves the network experience for a user in some aspect in comparison to the industry standard. Next slide, please. In our architecture, we utilize the WebView technology on mobile devices for both development agility and to develop across device, which even includes desktop, like consistent experience cross device. So in this architecture, the native code will be basic. It will be mainly to support the launch of WebView, fetch entry index page, and provide any native bridge calls if necessary to the WebView. Chatbot server is where most of our code will lie, and it will be the intermediate layer where we serve our UX to mobile devices and handle API interface with LLM. This is a pretty common architecture in the industry. Next slide, please. For the LLM part, we utilize the service of LongChain, which allows us to interact with different LLM models of our choosing through an API interface. Currently, we are integrated with GPT 3.5 Turbo. The chatbot server is a React front-end, Node backend monorepo served over an Azure VM using Docker container. And finally, for our new design, we implemented the WebSocket protocol for the communication between front-end and backend, which differs from the industry standard of HTTP for this kind of application. Next slide, please. Great. I'm going to show you a little demo on my Android phone here. Can you see my screen?
Yes, I can.
And in this section, we have the settings page, which allows us to select HTTP or WebSocket, disregard WebRTC because it doesn't actually work. But yeah, let's start with HTTP, and we can also tell it to actually use LLM or not, which will just, if not, it will just return like a placeholder response. And the test suite is for when we did our field test. So let's go back. If we go HTTP, if I say hi and send it, yes, it'll say, hello, how can I assist you today? Very good. And then we can switch to WebSocket protocol and go back, and we can do something more interesting. What's the weather like in Tokyo? Taking a little longer because it's a more complicated question, but it does respond. And the other thing I wanted to showcase is actually speech to text and text to speech. And unfortunately, I'm only able to showcase text to speech here, mainly because there's some weird issue when you try to use Zoom on your Android device. It kind of doesn't let me use my mic button here. But I'll get my friend Mohammed to show you, and he will just demonstrate on browser because unfortunately he doesn't have the environment set up for a mobile to demo on mobile. But I'm more than happy to show it in person if necessary. All right. To do text to speech, all I need to do is click on one of the message bubble.
Hello. How can I assist you today?
I hope we can hear that, and we can try something else.
What's the weather like in Tokyo?
Great. That's all I really want to show you here, and then I'll give the screen control back to Mohammed, and he can show you the other part, which is speech to text. All right, Mohammed.
Yep. Thank you, Leo. So, yeah, I hope you can see my screen.
Yeah, we can see our screen here.
Yeah, so let's move to the app and let's demo the speech to text. What is the weather like in Indiana in December? So as you can see that the speech is correctly converted into text, and then we can query and the LLM responds.
The weather in Indiana in December can vary, but generally, it is cold with temperatures ranging from around 25 degrees Fahrenheit -4 degrees Celsius to 40 degrees Fahrenheit 4 degrees Celsius. It is advisable to dress warmly and be prepared for potential snowfall.
Yes.
Amazing.
Yeah,
Let's
that's
move on.
about it for the demo.
Yeah, next slide, please. Yeah, so we have the field test. We have some Google Docs here, and we have Mohammed talk a little bit about this part.
Yes. So for the field test, what we did was that we ran 2 sessions of HTTP and 2 sessions of WebSocket. And
Mohammed, you didn't open the Google Doc if you wanted to do that. Sorry.
No, so I'll just explain, I think. So so we ran 2 sessions of HTTP and 2 sessions of WebSocket. And for HTTP, we ran about 10 queries for each session. And for WebSocket, we ran 10 and 11 queries for each of the session. When I talk about a session, so I'm talking about when you go, when we start, when we access this from the front end and then query, and then if we refresh, another session starts. Now, so we conducted these tests over 3 kinds of networks: our local home network, the PAL3 Wi-Fi, and the 4G LTE network. And we hypothesized that the WebSocket will perform better than the HTTP protocol when multiple messages are involved in the conversation, because WebSockets do not have that overhead of HTTP headers, and due to other reasons. So for every request that we sent, we so our methodology was that we timestamped the following events. We timestamped the client to server message, the server, when the server received the message from the client, when the server sent the message to the LLM, when the server received the response from the LLM, and when the server sent the response to the client, and when the client received the response from the server. And this round trip of messages from the round trip time from the message of the messages from the client to the LLM is marked by a unique exchange ID, and the entire conversation is consisting of multiple messages, and it is marked by a unique session ID. And so this timestamping allows us to aggregate the messages together and to extract out the factor that is of interest, which is the round trip delay between the client and our server. And so the longest round trip time message from the client to the server to the LLM to the server to the client, that took the longest time, and we subtract that from the round trip and the generation time of the LLM. Similarly for the shortest time. And the average time refers to the average round trip messaging time in a particular session, again without the round trip and generation time of the LLM. So by the network type, we saw that HTTP shows very high maximum latency compared to the WebSocket. So, and this could be due to, I think, HTTP's connection establishment overhead for each of the requests. And the average time for WebSockets is significantly lower, which suggests that maintaining an open connection, as WebSockets do, is more efficient on stable networks like the home Wi-Fi. When we moved to the PAL3 department Wi-Fi, we saw that the results were even more pronounced. The WebSockets' maximum and average times were considerably lower than the HTTPs, as you will be able to see in the linked document. And this might be due to the nature of the department Wi-Fi network, which could have more traffic and more stringent security measures. And for 4G, while the WebSocket still performs better, the gap in average time is less pronounced compared to Wi-Fi networks. And so
Yeah,
in conclusion,
just be conscious of time here because we do have a 15-minute limit.
I see.
And also, yeah, we should have really opened that Google Doc because it's not that helpful when there's no tables, data at all.
We are
But
really
it's okay. All the information is there. You can look at it. Do you have anything to wrap up, or should we move on to the next slide?
yeah. We can move on to the next slide.
Okay.
Okay.
Thank you. Next slide, please.
Just
Yeah, I would just quickly summarize what Taha or Mohammed is trying to say here. We really should have opened that Google Doc, but it's okay. You can look at it later. But in conclusion, we demonstrated a basic chatbot app that will work across the device and is flexible and it can interact with different LLMs with speech-to-text and text-to-speech functionality. We demonstrated improvement of using WebSocket instead of the industry standard of HTTP, which has shown promising result in different network conditions. As mentioned before, we're seeing quite a significant improvement on average time when there's multiple messages involved in a conversation. And yeah, that's very exciting. And then there are some caveats also. We realized that further research is needed regarding the use of WebSocket over HTTP in terms of different media streaming. One thing I can think of is that images are pretty popular, and that is not something that our app currently supports. And maybe in the future, audio, video streaming that needs to be considered. And we realized that further research is needed regarding the use of WebSocket over HTTP in terms of more network conditions needs to be tested, and we need massive amount of data before we can make a very sound conclusion on that point. And yeah, in terms of network condition, yeah, okay, great. We have the Google Docs here. Yeah, we did test a couple different ones, but I was more thinking of like different network condition, as in congested, peak hour, Lawson, where you can't even get Wi-Fi to connect, kind of thing. That would be interesting. But yeah, let's move on to the next slide. Yeah, some footnotes. Oh yeah, we're missing some links here, but it will be there when we hand this in. But we have the deploy link. We'll have our GitHub repo public, and we will have both this Google Doc, which is already there, and we'll also link to the raw data, which should be along with our GitHub repo. And I think this is our presentations. Yeah, if you have any questions, you can always feel free to contact me. Thank you.
Thank you.